We have previously learned about local maxima and minima, and now we're going to look at absolute maxima and minima. So what is the definition? So the mathematical definition states that if f of c is greater than any other f of x, so if this specific y value is greater than any other y value, for all the x in the domain of f, then it is called an absolute maximum. And if it's the opposite, if it's the smallest of all the y values, then it's called the absolute minimum. So an absolute max or min is called an absolute extremum. Now, what's important to know is that infinities are not considered an absolute maximum or minimum. So you can never answer that infinity is your absolute maximum. So try to remember that. So let's take a look at two different scenarios here. So the first function we have is x cubed over 3 minus 4x. And so we want to take a look at if there's any y value that's smaller than any other y value, or there's a y value that's greater than any other y value. So here, because this arrow is going down, it means that it's going to keep going to negative infinity for the y's. And because this is going to go up, it's going to go to infinity. It's never going to stop increasing on the right, and it's never going to stop decreasing on the left. That means that in the graph, there's absolutely no y value that is higher or lower than another y value. So in this situation, there is no absolute max or min. Okay, because again, infinities are not an absolute max or min. To take a look at another situation though, if I looked at 4 minus x squared and I was to see if there was a y value that was greater than any other y values, I would have one, and it would happen right here. In the graph, the whole entire graph on its whole domain, this y value will be the greatest of them all. So you have an absolute max at 4 when x is equal to 0. So at the point 0, 4. Now, because the graph is going to keep going down and it's going to continuously decrease to negative infinity, you have no absolute min. So hopefully that helps to see them kind of side by side here. Now, what happens, however, is that sometimes you can restrict the part of the graph that you look at. So if I was to only look at this parabola from, say, -2 to +1. So I'm going to erase this red dot, and I'm going to look from x is -2 to x is equal to 1. So now I would take a look at this, only this part of the graph. And if I'm only looking at the red piece, I then can ask, okay, well, on this specific interval, do I have a y value that's greater and do I have a y value that's smaller? And the answer is yes to both. You will have an absolute max at the same place as above. Okay, you would have an absolute max at the point 0, 4. So this is still the highest. And now the smallest y is going to happen at the y value that's the smallest, what's going to happen here. So you have an absolute min at -2, 0. So your minimum is happening when y is 0, and you have a maximum happening at 4. So now that we restricted the interval, the answer sort of changes. Let's take a look at a couple more examples here. So how are we going to locate where the absolute extremas happen? So if they happen, if they exist, it has to happen at critical numbers or at the endpoints of the interval, right? Because remember, now you're going to be given an interval, a comma b, and so it has to happen either at the endpoint, which you saw above, right? That's exactly what happened in our parabola here. It hit the minimum now at the endpoint of -2, and you also have to check the critical numbers. So where are the critical numbers? Remember that the critical numbers can happen where f prime of x is 0 or where f prime of x is undefined, but it has to be part of the domain. It's really good to always kind of think about the domain when you're working with functions. So that's what we're going to do in the next two problems. That's how we're going to start. So we want to find the absolute maximum and absolute minimum of f of x is equal to x cubed minus 6x squared on the interval -7, 2. So I want to think about the domain. because this is a polynomial, domain is all real numbers. You can plug in any x and you will get a y. So next I'm going to find my critical numbers. So I'm going to have f prime of x is going to be 3x squared minus 12x. I'm going to set this equal to 0. I'm going to pull out a 3x. That's going to give me x minus 4 is equal to 0, which gives me x is equal to 0 and x is equal to 4. Now, this little guy right here is never undefined because there is no x that would make it undefined. So it's only you need to check when it's 0. But the key is I'm only checking on the interval -7, 2. So this critical number is out. You don't need to check it. 4 is not between -7, 2. So you only are going to have to check 0, and the key here is to also check the endpoints. Very common mistake. So I'm going to check what is f of -7, what is f of 2, and my critical number, which is 0. And then I know it's an absolute max if the y is the greatest of them, and I know it's an absolute min if it's the lowest of them. So you plug it in and check what you get for y. So here I'll get -7 cubed minus 6 times -7 squared. And when you plug that into your handy dandy calculator, you're going to get -637. Then you're going to plug in 2 cubed minus 6 times 2 squared. And when you plug that into your handy dandy calculator, it will give you -16. And when you plug in 0, the easiest, you'll get 0 because there's an x in each term. So which one is the smallest? Well, the smallest happened at -637. So that is your absolute minimum. So the absolute min is going to happen at -637 when x is equal to -7. And you're going to have an absolute max at 0 when x is 0. So here's your absolute min and max. So again, what were the steps? Look at the domain, find your critical numbers, and then test your critical numbers and your endpoints in the original function. Let's do one more to solidify that. So we want to find the absolute max and min of f of x is equal to 1 minus x over x squared minus 1 and we're actually going to change this from 2 to 5. And I'm going to explain why we want to actually change that. What was the issue with the other one? So the first thing we're going to do is we are going to look at the domain of this function. So I have f of x is equal to 1 minus x. And x squared minus 1 is a difference of squares, which factors to x plus 1 times x minus 1. So the domain of this function, is all real numbers, except x cannot be -1 or 1. So the reason I had to change the interval is because when you're looking at absolute maximum and minimum is you need to look at a continuous interval. And so here, because it gets the -1 and 1 were in this interval, the interval would be discontinuous. So from 2 to 5, the function will be continuous. So next I'm going to find my critical numbers. So I'm going to have f prime of x. I'm going to have to use the quotient rule for this. So the derivative of the top is -1 times the bottom, x squared minus 1, minus the derivative of the bottom, which is 2x, times the top, which is 1 minus x, all over x squared minus 1 squared. So I'm going to clean up the top. So I'm going to distribute the -1. So -x squared plus 1 minus 2x plus 2x squared all over x squared minus 1 squared. I'm going to combine some like terms. That's going to give me a positive x squared minus 2x plus 1 all over x squared minus 1 squared. So I'm going to look when this is 0. So when I set this equal to 0, only the top will be 0. X squared minus 2x plus 1 is equal to 0. This factors really nicely for us. X minus 1 squared is equal to 0, which means that x is equal to 1. But there's two issues with this. One, it's not even in the domain, and it's not in the interval we're looking at. So I'll write both, or interval. Okay, so when it's equal to 0, it doesn't give us any critical numbers. Then I'm going to look at where it's undefined. It will be undefined when the bottom is 0, so x squared minus 1 is equal to 0. But I already solved for this. This gives me 1 and negative 1. But again, for the same exact reasoning, both of these are out because they're not in the domain or in the interval. So I have no critical numbers. So the only thing I need to test are the endpoints. So I'm going to have f of 2 is going to equal to 1 minus 2 over 2 squared minus 1, which will give me a negative 1 over 3. And then I have f of 5, which will give me 1 minus 5 over 5 squared minus 1, which will give me a negative 4 over 24, which will reduce to negative 1/6. Now the question becomes, which one of these is smaller and which one of these is bigger? So if this is 0, the negative 1/6 would be closer to 0 than negative 1/3. So this is the min and this is the max. So I have an absolute min at negative 1/3 when x is equal to 2. And I have an absolute max at negative 1/6 when x is equal to 5. And here's my final answer for this question.